In this video, I discuss this phenomenon known as the horizontal stretch and compression. This issue has always confounded me, and it's always seemed counterintuitive until I realized that the property that unlocks everything has always been there. And that is simply that with the horizontal transformation, it is the y that stays the same. So if I put in my 3 into this basic quadratic, I get 9. In this transformation, I enclose a 3 inside the parentheses. I know what my y has to be. I do a little algebra and I determine that my x will be 1. And finally it dawned on me, this is where that division comes from. In this case, my input for x gets some help. It gets help with that factor greater than 1 in this case, the 3, before the squaring takes place. Order is everything. It's x, my input gets some help. In this function, instead of the 3, I make that my internal factor there 1/3. Now the x not only is not getting help, it's being hindered. Now x has to do, in this case, 3 times the work to offset or to compensate for the 1/3. So I know my output is 9. I do a little algebra. I see that my x has to be 9 to overcome the 1/3. When I graph these points, here's my original, my plain pizza, if you will. When I include the factor greater than 1 inside, here's my compression, closer to the y-axis. When my factor is less than 1, here's the stretch. So instead of being confounded all these years, it makes perfect sense.